Hello, this is Mr. Stansbury. I'm going to take you through the notes on the addition law of probability. At the end of this, you should be able to say, I can use the addition law of probability to solve mutually exclusive and inclusive event problems. Okay, so first let's talk about what that means. So compound events is where there is more than one event or in our sample space. Okay, so suppose that there are two events, A and B. Okay, so this would be A and this would be B. Okay, the event that both A and B occur is this here. A, we call this A intersect B. It's where A happens and B happens. Okay, and then the event that A or B or both occur is A union B. So either A happens or B happens or both happen. Okay. Inclusive events is where two or more events have one or more outcomes in common. Okay, so for example, people who like hamburgers and people who like hot dogs. So this first group here would say be the hamburger people, and that would be the hot dogs. Okay, so you can see that there's a group that like hamburgers, just hamburgers, a group that likes just hot dogs, and there's a group that like hamburgers and hot dogs. So what we would do is we'd take all the people that like hamburgers and we'd add them to all the people that like hot dogs, but then we'd have to subtract out the people that like both hamburgers and hot dogs because they got counted in two different spots, right here and right here. Okay, so that would be the probability of A union B is going to equal the probability of A plus the probability of B minus the probability of A intersect B, right? And this is the addition law of probability. Okay. Mutually exclusive events are events that have no common outcomes. For example, rolling a 3 and rolling a 4. So this would be the probability of rolling a 3. This is the probability of rolling a 4. So that's just going to equal the people, the time that you roll a 3, the time that you roll a 4, and you don't have to subtract anything because there's no overlap. You can't roll a 3 and a 4 on one roll of the dice. Okay? As displayed by this. Okay, let's take a look at an example here. Example 12. If the probability of A is 0.6, probability of B is 0.5, and the probability of A union B is 0.8, find the probability of A intersect B. Okay, so let's draw ourselves out these Venn diagrams, and that should help us figure this out. Okay, so here's a big Venn diagram that we can use. So here's A and here's B. It says the probability of A happening is 0.6, probability of B happening is 0.5, and the probability of all three of these happening here is 0.8. So for all three of these is 0.8. That means, since this whole thing always has to add up to 1, if we take 1 minus 0.8, that gives us 0.2. We got 0.2 out here is the probability that neither one of them happen. Okay? So if we add up 0.6 and 0.5, that gives us 1.1. But we know that we can only have 0.8. So we take our 1.1 minus 0.8, and we get 0.3. So there are, that's 0.3 is the part that got counted twice. So that means 0.3 would be in here, just the A, because 0.3 and 0.3 is 0.6. And then if this is 0.5 in here, we've already used 0.3, so that leaves us with 0.2 here. And then remember, if we add all three of these up, 0.3 and 0.3 is 0.6, plus 0.2 is 0.8, plus 0.2, that gives us our 1, which is everything that could possibly happen. Okay? All right, we got one last example, but before we do that, let's take a quick comedy break. All right. Last example here. Example 13. Of 70 people in the UBL, Unicycle Basketball League, 21 people's scoring average is between 15.01 and 20.00 points per game. 28 are between 10.01 and 15. A player is randomly selected. Let A be the player scoring between 15.01 and 20, and B be the player scoring between 10.01 and 15. Okay, so let's create ourselves a Venn diagram for that. So first thing we're really going to want to do before we put on our Venn diagram is we want to figure out, are A and B mutually exclusive? So mutually exclusive, remember, means that can they both happen at the same time? Okay, so these two events, you can't have an average between 15.01 and 20 and 15 and 10.01. You can't have two different averages. Your average is going to fall between one of those two ranges. Okay? Okay, so since they both can't happen at the same time, that means that they are mutually exclusive. So yes, they are. So we want to include a Venn diagram that does not have overlap. You can actually have one that has overlap, but then there's just going to be nothing in the middle. Okay, so here's what our Venn diagram should look like. Okay, and it says here, let A be the players scoring between 15 and 20. So this is going to be group A, and B is going to be the players scoring between 10 and 15. Okay, so we have 28 that are scoring between 10 and 15, right? And then 21 are here between 15 and 20. Okay, find the probability that A happens. So that would be 21. Again, if we're assuming that we're picking from everyone, which what I would assume that we'd have to do, of the 70 total people, so that's going to be 21 of those people are in A out of the 70 total. Okay, and that gives us 30%. Okay, probability that are of the people that are in B, so that would be 28 out of the 70. Okay, and that gives us 40%. Okay, probability of A union B, so probability of A happening and or B happening. So that would be both. So that would be the 21 plus the 28 all over 70. So that's going to be what? 49 out of 70, which is going to be 70%. Okay. And then the probability of A intersect B. So that means when they both happen. And since these are mutually exclusive, they can't both happen. So that is 0 out of 70, which is 0%. Okay. All right. That's all there is for the addition law probability, excuse me. If you have any further questions at all about this, please feel free to ask in class. Thanks.